Data Skeptic features interviews with experts on topics related to data science, all through the eye of scientific skepticism.
Joe Hardin has a PhD in statistics from UC Davis and is presently a professor of mathematics at Pomona College. Her work contributes to diverse topics such as computational biology and genomics. She recently wrote a blog post about the prediction competition for the U.S. 2016 presidential election, giving some tips for competing. And with the election coming up, I thought it would be a great time to talk about how data scientists can study the election process. Joe, welcome to Data Skeptic.
Thanks. Great to be here.
Before we jump into the details and election discussion, could you tell us what the ASA is and what your particular association is to it?
The ASA is the American Statistical Association, and I'm involved. I have a couple of roles. I work closely with the statistics education section and their outreach to students of all different kinds. I also work locally with my chapter in Southern California.
And what can you tell me about the ASA's prediction competition?
I think it's just a way that the ASA came up with to really get students excited and involved with how you can use statistics to think about what's going on in the news and really kind of current events. The prediction competition is pretty straightforward. It's simply to predict both the winning presidential candidate as well as the final percentages of the popular vote for each major candidate. And I think they want it also, if you can also do it, per state and then broken down by demographic groups and whatnot. They want a thoughtful answer. They've asked for 200 to 300 word description of the methods and what you did that was original. They're not really looking for you to just report, what Nate Silver has predicted. But it's kind of a fun thing, and you can work in groups, and there's a $200 cash prize and an opportunity to write it up as a blog, whatever it is that you come up with.
Oh, very cool. When I first read this headline, I started out slightly cynical, thinking, well, realistically, in the United States, one of the two major parties wins. No offense to third-party candidates, best of luck to everyone, but it's sort of a binary outcome in our country. So if it's a coin toss, I've got a 50-50 shot of making a correct random guess. But how do those added features they're looking for make it a much more interesting and difficult challenge?
Well, I think the challenge is sort of twofold. Obviously, we're going to be looking for more than just a binary response. But in terms of predictions, the two pieces that are so important are what data do you use and what methods do you use? And so there's lots of ways to contribute on those two different fronts and ways to talk about your choices. As most of your listeners will know, there's lots of polling organizations out there, and every time they come out with a new poll, it's slightly different from their neighbor polling organization. Kind of thinking about which polls you're going to use and how you're going to combine those results. And, I think there's a lot of interesting ideas, creative ways to look at the problem.
Absolutely. I really like your distinction that there's data and there's methods. They're two separate and important things. Maybe we should start with the data. Can you tell me about some of the sources you identified in your blog post and what differs across them?
I give a couple of different places that you can find data that poll aggregators. So they've taken polls from lots of different sources. I actually use the data from 538. To be honest, the main reason I used that particular data is because I could scrape the data in a reproducible way. I wrote some code that would allow me to run the code over and over so that every time there's a new poll posted, I get a new set of data. I think that the majority of the base data that goes into these poll aggregators, so Huffington Post or Real Clear Politics or Gallup, that they're using a lot of the same polls, but what differs is how they weight the polls. Some of them will make choices on not to use a particular poll if it comes from a really liberal polling organization or a conservative polling organization. Just today I was looking, and Daily Kos says, I don't know if I've said that right, Daily Kos says that Hillary Clinton has a 72% chance of winning, and Nate Silver of 538 says Hillary Clinton has a 67.6% chance of winning. So, you're definitely going to get some differences across these different poll aggregators.
So you zomed in on 538 as a data source. Now that data isn't just delivered to you in a nice package on your doorstep. There's some steps to get it. Could you talk about the code you wrote for the scraping and analysis and some of the challenges in putting that together?
So one of the big challenges that I had is that when you go onto the 538 site, there's an XML page that just pops up at you. And that was actually pretty straightforward for me, just using the XML package in R. I should say that I did all of my work using R Studio. But the problem was that I only got the top 10 posts, or the top 10 polls, rather. I wanted more information than that. I thought, okay, if I'm going to be predicting this, I want to go out, go back farther into the poll history and kind of see what the trends have been. And I was interested in doing some visualizations and whatnot. If you are on the website, you simply click a button and you get, I don't know how many, 40 or 50 different polls that will show up. And so that caused me to really kind of delve into, Stack Exchange and reaching out to friends I have who are more expert in this. I ended up using both rcurl and readr, which are additional packages, R packages, to read HTML files. But then the key was that the data I ended up downloading into R was JSON. And if any of you have worked with JSON files, they're like lists of lists. So they're just these nested pieces of information. And so there was a reasonable amount of data manipulating to work through that. And I've documented all that in the code that I posted on GitHub.
Oh, that's great. I'll put a link to your GitHub repository in the show notes for anyone that wants to check that out. What would it take for someone to use your code to kickstart their own analysis leveraging 538 data?
So if they want to use the 538 feed that gets updated daily, they can just rerun my code really straightforward. Literally, I've written an R Markdown file, and the R Markdown file is posted on GitHub. So I've written, the first half of the R Markdown file is scraping the data and getting it into tidy format. If they just kind of start halfway through, the data are in tidy format, which means they've got, variables as the columns, and then the polls are the rows, and they can just go from there.
Oh, that's great. That could be a big time saver for some of the participants in this competition. So if I were to grab that, perhaps it's time to get into some of the methods. You did some initial analysis, independent of your own political perspective, which you're free to share or not, however you choose. But what did the data tell you when you did an initial run-through of it?
One of the things I was surprised by, and maybe it's because I haven't been following along as closely as some people, but I was surprised that Trump has virtually never had a lead over Clinton. When you're aggregating these polls and kind of thinking about weighted averages and trends and tallying things as they go along, I was surprised at how consistent they've been over time. From my statistical perspective, as a statistician, the thing I think about every day is variability. And so for me, believing that there's this baseline of Clinton having possibly a 4-point lead, then I would exactly expect that some polls should show them tied, and other polls should show Clinton ahead by 8 points. That's just the nature of variability. And so that to me says consistency, whereas to other people, a swing from 0 to 8 might seem like extra variability.
So from a purely statistical sampling and inferencing approach, it seems like when we look at polls, they're trying to answer the question, who is America's current favorite candidate? Yet this is not necessarily the same question as who will win the upcoming election. Why not?
I mean, when you ask who America likes, you have to think about who America is. Who's going to win the upcoming election depends on the individuals who go to vote on election day. Polling organizations try very hard to figure out who those people are. It has to do, of course, with people who are allowed to vote. There's lots of ways that individuals are sort of disenfranchised in terms of their voting. We know about some, like, if you're under 18 or if you're a felon, those are people know about. But other things that people may not know about are that voter rolls sometimes get purged. So, kind of cleaned up, and reasons might be because you've moved. So they go in and they look and see who has moved recently, and those people are required to re-register to vote. Sometimes they get purged, and I'm not exactly sure about all the legalities of all this, but sometimes they get purged simply because people haven't voted in a number of elections. So if you haven't voted in some number of years, and I feel like I was reading some articles that just happened recently in Ohio, that people who haven't voted in the last, 3 or 4 elections are being purged from those voter rolls. So really we want to know, not just when I randomly digit dial someone, who they like as a candidate, but I also really need to know who is going to vote. Are you going to show up on election day?
So in your analysis, you chose to do a weighted average. I think the idea of weighting a set of independent sources is pretty uncontroversial, but perhaps the one matter of difference of opinion could be the way in which you choose to weight them. What did you use and why did you choose that method?
I was just kind of playing around with what I sort of think about when I'm looking at these polls. I think, how long ago was that poll? How many individuals did they survey? What does 538 think? Because the data that I scraped from 538 actually reports the weight associated with the poll. I'm not sure that my weights in particular are particularly scientific, but it is important to know that some of these polling organizations have particular leanings, and the way that those leanings get manifested in the outcomes of the polls have to do with how the question is worded or what the order of the question is. You know, if you ask about particular political events and then you ask which candidate they're going to vote for president, that can really impact that response. And so I think these poll aggregators know a lot more about those particular nuances, but I also think they take into account those standard things. For example, how long ago was it? Has political opinion changed over time? And how many individuals are being sampled?
So doing any sort of polling opens up an opportunity for us to have a statistical discussion about how it was sampled. In a perfect world, obviously, we're doing the equivalent of pulling colored balls out of urns in an independent and identically distributed fashion, but we don't necessarily have that pure access for a lot of reasons. You've given a bunch of them already, like people who are able to vote and will show up at the polls on the right day. I think it's difficult to take a measurement. What do you think the chances are we're able to actually measure something close to ground truth value?
Well, I think another thing that I haven't talked about yet, which really has to do with this measuring question you're talking about, is how we're getting in touch with people. 30 years ago, everybody had a landline, and there were pretty standard ways of doing random digit dialing where you were really getting a good representative sample of the US population. And then you could easily ask things like, did you vote in the last election? Or did you vote in the last presidential election? And that was a way to gauge whether that person was likely to vote in the upcoming election. But now, I want to say like 20% to 25% of people don't even have a landline. You know, I have a landline, but I almost never answer it. Right. So the number of individuals who can be contacted, or really the type of individual who can be contacted via a landline, is really changing how we're measuring things. And so there's all sorts of different ways of measuring. There's also internet panels. So people who sign up to be asked questions on a regular basis. Those are a cross-section of the United States, and we're trying to get a representative view. But making sure that, as I was saying with cell phones, obviously the majority of people who have cell phone only homes are going to be young people. And obviously, you know, young people have different political interests than baby boomers.
True, yeah. So there's a strong correlation there that we're going to get a sampling bias from if we're only counting opinions of the people who answer landline calls. But can we correct for that? Is there perhaps a small population of young people with landlines and we can oversample or something like that? Is it hopeless, or is there something we can do methodologically?
I do think we understand some of those demographic categories. A lot of these polling organizations weight based on exactly race, age, education. You can oversample from particular geographic areas to get those internet polls, internet panels. Sometimes those are arrived at through randomly sampling addresses, right? Literal home addresses. Home addresses is something that we definitely understand demographics of, right? We understand towns and what their racial breakdowns are and their education breakdowns.
So there's a lot of ways we can go at this. I'm really intrigued by that one of picking addresses because you can really well control and hopefully go knock on doors enough times that you get a response. That compared to internet panels where there are very different methods for coming up with the data. Is there any statistical reason why we should say there's a preferred data collection process, or is it all pros and cons?
I think you have to use all of them, right? If you think about your nephew and your grandmother, there's no possible way for you to get information from both of those demographic groups using one method. So I really think that any polling organization that's going to have accurate information is going to be combining results from lots of different methods. And I think they all have pros and cons. And I guess I would boil it down to the pros to all of them is that they reach a particular demographic, and the cons to all of them are they don't reach a particular demographic.
You'd also mentioned online polling, which is something I happen to know a little bit about. A technique that is used sometimes in the online polling space is to set some nice strata for yourself on, I guess, some sociological analysis and things like that, and say that we need people of these particular criteria and these quantities. As those buckets fill up, you're getting them, but one bucket gets full, you start turning people away, essentially saying, we're not interested in your opinion because we already have enough people that look, talk, walk, and act like you. What's a statistician's perspective on turning people away like that versus trying to balance later?
My instinct is to say that you have to really think about which one's going to bias your answers more strongly. So if you're really aggressively trying to get people, that to me says that there's something sort of different about the people that you're getting than that you're not getting. But again, I'm sure, there's so much that goes into it. It's not just the demographics, but it's also the psychology of an individual who wants to answer a poll versus the psychology of an individual who doesn't want to answer a poll. So really that's, I think, where the analyst needs to be careful, is just thinking carefully about how am I going to bias my answer, my polling, and I want to do that as minimal as possible.
So I see a lot of polls, the good ones, at least in my opinion, will report a margin of error around them. Yet as far as I know, that margin of error is arrived out of some set of methodological assumptions that aren't often stated. Maybe they just take some simple confidence intervals. We don't know that they check the underlying assumptions. These sorts of concerns can come up. How do you as a statistician interpret the margin of error in a public forum like on a news broadcast?
First of all, before I answer that question directly, I think, again, 30 years ago, when the majority of polling information came straight from random digit dialing, I think the margin of error was almost purely based on the sample size. And that really makes sense from a statistical point of view. If you're randomly sampling, then the only thing that matters is how big a sample. And you don't need, a huge sample. 1,000 people will get you a margin of error of 3%. Mm-hmm. Nowadays, because we're combining methods and it's just a lot more complicated with weights and whatnot, those margin of errors have more sophisticated formulas going into them. But I think that there's been a lot of thought, and I don't really question the margin of error in terms of how it's been calculated. Now, in terms of what it means, what I think when I see one individual poll with a margin of error of, let's say, 3%, I'm thinking to myself, okay, well, if I look at 100 different polls, 95% of those polls are going to capture the ground truth, and 5% of the polls are not going to capture the ground truth. Mm-hmm. If I'm only looking at one poll, I'm an optimistic person. I tend to think, okay, well, the ground truth, whatever that means for today, is within that margin of error. So if it's 52% plus or minus 3%, then, okay, well, 49 is in that margin of error. So, it could go to the other candidate. It also helps me understand when I see an extreme poll that we're looking at so many polls every day in this election season that it makes sense that we would see some extreme polls here and there.
Oh, that ties it actually into one of the later stage questions I wanted to ask you about. As I was doing some background research for this episode, I noticed you've done a lot of work in areas that are very familiar to the data skeptic audience, things like clustering and outlier detection. In particular, I noticed you're doing some work on false discovery rates, which in my opinion is an undervalued aspect of statistics. Could you talk a bit about how we might think of false discovery rates in the context of the election predictions?
They're related, but different. So when we're trying to do inference, we're interested in what's going on with a population. I often, when I'm teaching courses and whatnot, talk about two different pieces of inference. And one is hypothesis testing, where I have a very specific question that I'm trying to ask. And one is interval estimation, so confidence intervals and prediction intervals. False discovery rates come about through hypothesis testing, where I'm making a decision. I'm deciding to reject a particular null hypothesis or to not reject that particular hypothesis. And so a false discovery rate is how often I get a data set that I think is a positive, but is really only noise. With estimation, you don't have quite that same idea because I'm not really making a decision about is candidate X going to get the 50% of the election? Instead, what I'm saying is what is the percentage? And so that estimation is slightly different because I don't have a yes-no vote. So it's not quite the same context.
Makes sense. So winding up, when we were talking earlier about better methodology or better data being the right step, what do you think is more important in coming up with a really accurate election prediction?
I think that being simple, creative, and thoughtful are really the keys to a competition like this. It's hard for me to believe that a really fancy theoretical model is going to predict much better than a thoughtful, nuanced model. So I sort of believe that the person who's going to win this competition is going to be someone who understands the nuances of the political system and the different polls and has thought carefully about how to combine them in creative ways.
I think that's some good advice. There's a lot more good advice in your blog post, and I'll remind everyone that that will be linked to in the show notes, as well as your GitHub repo where they can check out your code and perhaps leverage some of that in the competition. Any final words of wisdom for people that want to take on this challenge?
I would implore everyone to go vote. If you don't know if you're registered to vote, just go to Google and type, "How can I vote?" And Google will actually tell you whether or not you're already registered to vote.
Oh, that's super cool. I didn't know that. I hope everyone does that. Joe, this has been really interesting. Thank you so much for coming on and sharing your thoughts with us.
Great. Thanks so much for having me, Kyle.
Take care.
Bye.
So one quick final detail before we sign off. If anyone listening is actually going to participate in the ASA competition, I'd like to hear your story. Share it on the show's Facebook page. I think that's the best spot because you can kind of post a longer thing there. You can also tweet at me if maybe you blog about it, something like that. I'm really interested in following what goes on with this. And if there's a good number of listeners participating, perhaps we'll do a follow-up show about it. So if you're at all interested in this, I think it's a cool opportunity to work on a real-world problem, maybe get some feedback on your work. So let me know if you're going to join. And until next time, I want to remind everyone to keep thinking skeptically of and with data.
For more on this episode, visit dataskeptic.com. If you enjoyed the show, please give us a review on iTunes or Stitcher.